All right, y'all, as promised for some of you, or to some of you, I'm going to go through and create a video here, kind of going through step by step how to solve the problems for this week's check-in, right? Because I know some of you seem super comfortable, some of you are struggling a little bit, so I hope that this helps. Our first question, use the spinner. Use the spinner to answer the following questions. What fraction of the spinner is shaded gray? Well, I think the easiest way to approach this is to make sure that our spinner is broken into even pieces. It now is. It's got 8 even pieces, and 3 of those 8 are gray. 1, 2, 3. So we're looking at 3/8. Now suppose that you spin the spinner 72 times. How many times would you expect it to spin on the gray or to land on the gray? Well, if 3/8 of the spinner is gray, we're going to multiply that by 72. So this might be a refresher for some of you. When we are multiplying fractions by a whole number, it's helpful to put that whole number over 1. So 3/8 times 72 over 1. And it's totally fine to use a calculator here. So what do we have? 3 times 72 is 216. And then again, multiplying fractions, we multiply straight across our numerators and then we multiply our denominators. So 216 over 8. And if we do that division, we land on 27. So you could expect that spinner to land on gray 27 times because we were finding a fraction of the spins. All right, so if you spin it 72 times and there 3/8 of the spinner is gray, 3/8 of 72 is 27. Moving on. And this one was definitely tricky, and I know that. So use the diagram of the dartboard in Dominic's basement to answer the following questions. So what is the probability that the dart thrown will land in section C? So section C, we're talking about this guy and this guy. So the way I approached this problem, I noticed that the top bar is broken into 4 sections, then 1, then 2, and then 3, right? 4, 1, 2, and 3. And I know, looking at 4, 1, 2, and 3, a common multiple of 4, 1, 2, and 3 is 12. So if we were to break each of these into 12ths, and just for the sake of a visual, let's actually do that. I know it's not perfect, but it is not the worst. So if we've broken this into 12ths, right? So each of these, the 4ths on the top were broken into 3rds. Our section B, that one long one, is just in 12ths now. Our A and our C right here, those are each in 6ths. And then down here, our C, A, and A, those are in 4ths. Well, if we look at what we have here, I see the entire block now, right? Because that's our whole. If we broke this into 12ths, 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 our denominator is 48. There are 48 possible little spots that you could land. Right here, we've got 6 of the 48. And right here, we have 4 of the 48. And 6 plus 4 equals 10. So 10 48ths is our answer, and that was a correct answer. However, we can simplify that. We cut it right in half to 5 24ths. So both of those answers I accepted as correct, even though the 10 48ths was not simplified. Moving on. The faces of one 6-sided number cube are labeled 1, 1, 1, 2, 2, and 3. And the faces of a second cube are labeled 0, 1, 2, 2, 2, 3. The 2 cubes are rolled and the results are added. So what is the probability of rolling a sum of 1? Finding any probability with this, because there are 6 of each, 1, 2, 3, 4, 5, 6, yep. And actually whether or not there were, you could use a tree. You totally could, but imagine that we did that. 1, 1, 1, 2, 2, 3, and then we'd have to have 6 branches off of each of these. It gets really cluttered and really busy. This is a great time to use a different area model. Is that 6? 1, 2, 3, 4, 5, 6? I think so. 1, 2, 3, 4, 5, 6. Cool, and we'll just use the grid that's in there. So our first cube will go along here, and we have the options of 1, 1, 1, 2, 2, and 3. And then our second cube is a 0, 1, 2, 2, 2, and a 3. So now, in this space, let's go ahead and find the sums of if we were to, roll these two dice and add them together. Well, a 0 plus any of these. And then let's see, 2, 2, 2, 3, 3, 4. 1 and a 2 is going to be, whoa, sorry about that. 3, 3, 3, 4, 4, 5. And then those will be the same. And those will be the same. And then we'll have 4, 4, 4, 5, 5, 6. Okay. So here in the inside of our area model, we have the sums if we were to roll these dice. So what is the probability of rolling a sum of 1? There are 3 times that could happen. And how many are there altogether? Well, if there are 6 options over here and 6 options over here, 6 times 6 is 36. So 336, if we simplify that, 1/12 is our answer. And now, let's see if I can make my eraser small enough not to mess this whole thing up. There we go. What is the probability of rolling a sum that is not 1 or 6? So in this case now, we don't want to get a 1, and we don't want to get a 6. So if there are 36 total possibilities, and there are 4 that we're trying not to get, what are the other options? We do 36 and we subtract 4. We get 32 36ths. And we can simplify, can we simplify that? No, I think we're just going to call that 32 36. All right, I hope that this was helpful.